we had left off talking about 5 different ways to prove triangles congruent. We had side, side, side. We had side, angle, side, with 2 sides and the angle included between them. We have angle, side, angle, 2 angles on the side included in between them, angle, angle, side, and hypotenuse, leg, where we need a right triangle. If we got the hypotenuse and leg of that triangle, then we can be all set up. So we are going to work on the last page of the notes today. And on each problem, I'm going to be looking for 4 things. 4 things for you to answer. Number 1, if there is something new that you are marking in the diagram, then you need to explain how you can mark it in the diagram. Usually that's going to involve one of 2 things, either reflexive property or vertical angles. Reflexive property is if there's a shared side. Vertical angles if there's 2 angles right across from each other. That's question number 1. Question number 2 is, are the triangles congruent? And if they are congruent, then which of those 5 postulates are we using? We have side, 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 angle, 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 side, hypotenuse, leg. Or you would just say they're not congruent. And then you wouldn't have to do the last 2 things. Number 3, if you say they are congruent, you say which one of these we're using, then you need to say what transformation we're using. Is it a translation, rotation, or reflection? And then number 4, we're going to write a congruent statement. We're going to say triangle ABC is congruent to what triangle? So that's what we'll look at doing today. We'll do one together. Here we go. First one. Again, we're going to skip around some of these. Anything that I don't do here, you're going to do on your own. We got M, N, O, and we have R, O, N. So we have these 2 triangles. Anytime you see a right angle here, you need to put hypotenuse, leg as a possibility. Because hypotenuse, leg only works in right triangles. So that's a clue that we might be looking at hypotenuse, leg. Doesn't guarantee it, but we might. Another way to say it is that if you don't have a right triangle, then you can get rid of hypotenuse, leg as a possibility. So we have that right triangle. We also have a side here. And we also have this side, O to N, that is shared between the 2 triangles. It is a common side in both triangles. So it has to be congruent to itself. That is the reflexive property. That is the reflexive property. Then I know these triangles are congruent. This does turn out to be a hypotenuse, leg. Here's the hypotenuse across from the right angle, and then here's one of the legs that builds the right angle. So I got a right triangle, I've got the hypotenuse, I've got one of the legs. Remember I said yesterday that those are the 3 things that we need to prove hypotenuse, leg. I need hypotenuse, I need a leg, and I need a right triangle. The leg is that reflexive property that we just did. The hypotenuse is this side in blue across from the right angle. And then right triangle, well, it's got a right angle. So this is hypotenuse, leg. So that's step number 2. Step number 3, I want to know if it's a translation, rotation, or reflection. Well, in this case, if it were a reflection, I would flip it and the point would come down here. This is actually, point M is getting turned around this way to come down to R. So since it's getting turned this way, that's a rotation. So there's step number 3. Step number 4. Step number 4 is to say that the triangles are congruent. So I have triangle MNO is congruent. Well, M rotated and matched down to R. Point N, when it got rotated over to the other side and rotated over to O. And O, same thing, it got rotated over to N. So that's the order that we want to write these in. So we're using hypotenuse leg, that's a rotation. So there's your triangles being congruent. Next, I'm going to start getting responses from you here. I won't ask you to do the whole problem, but I'm going to ask you to do some steps. So first off, this once again has the reflexive property. So I want you to tell me where the reflexive property is. Which side? The reflexive property here, the shared side, is this side right here, A to C. A to C is the side that's in both triangles. All right. So here's a pair of sides. Here's a pair of angles marked over here. Or sorry, there's a pair of sides marked. This is a pair of angles. So I have a pair of sides here, pair of angles here, pair of sides here. So my next question is, this is not side angle side. So my question here is, why isn't this side angle side? That's one of the reasons why we can't use side angle side. A to C, the side that matches with A to C on the bottom triangle is, well, A to C. It's the same side. I have angle B on the top triangle. The angle that matches with angle B on the top triangle is angle D. And then on the bottom triangle, I have A to D. The side that matches with A to D on the top triangle is nothing. There's nothing matching on the top triangle. So because these two sides are marked in the same triangle and not in different triangles, we can't match them up. So this is not congruent. This is not congruent, so we don't have any of these. It's not a translation, rotation, or reflection, and we're not going to write a congruent statement because they're not congruent. But going back to this one, our reflexive property this time is E to G. It's the shared side in those two. Not every problem is going to have reflexive property. It just happens that the ones we're looking at right now do. The main ones we're going to have are reflexive property and vertical angles. So a lot of these have a side that's shared between the two of them. So we do have two sides and then the angle included between them. So this is side angle side. Split on this one. This one's pretty close. So an easy way to see is to keep track of where a certain point went, especially if you have an angle, because it's easy to keep track of an angle and where it goes. So if I were to take this and flip it, here's my index finger. That's where my angle E is. It needs to go down to angle G. Let's see if I flip it, it goes over to angle G. Nope, still up here. So that would be my flipping. That's where it would go if it were a reflection. Let's rotate it and see where it ends up. Again, index finger right here. Turn it, and it ends up down here where it's supposed to. So this is a rotation. This is a turning, and you can tell because angle E here went down to angle G over here. So keep track of where the points and angles go. That's where you want to work through. So then we can write our congruent statement. Triangle D, E, G is congruent to triangle. Well, D matches up with F. E, remember when it turned, it went down to G. And G, when it rotated, went up to E. So that is my congruent statement here. DEG is congruent to triangle FGE. Questions on that? Easier way to see if the angle is included is to just focus on the sides and angles that we're interested in. So here's the two sides with tick marks, and here's the angle with the tick mark. Let's take away the rest of the diagram. Oh, the angle is included between the two sides. So just to show you what it would look like if the angle weren't included, let's take this one where I have two angles here, and then I have two sides. I got this, I got reflexive property. Angle, well, it's off over here. It's not the one that's included between the two sides. So that's your difference between included angle and not included angle. But this one does have the included angle, so we can do this by side, angle, side. Next, by the way, there's not a right angle here, so you should be able to eliminate hypotenuse leg if there's not a right angle. Next, we have a translation, rotation, or reflection. Again, keep track of where a point goes. Point D should wind up at point S. Well, if I rotate it, nope. But if I flip it, point D flips over to point S. So this is a reflection. And so finally, let's match up the congruent statement. So I'm going to ask you to fill in the blank. Triangle KDA is congruent to, what would I match up KDA with? Your answer should be 3 letters matching up this triangle with the points on the other triangle. K, guess what? K matches up with K. D on this triangle matches up with, on the other triangle, S. And then A matches up on the other triangle with T. So K, S, T is how you want to fill that in. Questions on that one? All right, we're going to do one more together, and then I'm going to be asking you to do the rest on your own. So someone did pinpoint the angles we're going to use, which are these. Those angles, we talked about them back in chapter 1. Here are the two lines crossing. These angles are just right across from each other. These are vertical angles. I'll be putting up some vocab for you to study from so that you can remember what these look like. That's why we talked about vocab so much, because a lot of it's going to come back over the next couple weeks. So these are vertical angles, the angles right across from each other. So now we have that third piece of information. So multiple choice, which one of these are we going to use? Hopefully, you're between two here, because we have a pair of angles, and then we got another pair of angles, and then we have a side. So two angles and a side should be between C and D. Right? Since we got two pair of angles and a pair of sides, those are the ones that are two pair of angles and a pair of sides. Once again, I'm going to trace out, here are the two angles, here's the side, and we're looking at, is the side included between the two angles? Because if it is, we're going to say that it's angle side angle, to say that the side is in between the two angles. Here's the side, here's the two angles. Nope. Side is not in between the two angles, it's off over here. So that means that we are using angle, angle, side. Flexion. And this time, T, if I turn it, winds up down at U. This is a rotation. And just to finish off very quickly, where did H on the bottom wind up on the top triangle? And U wound up at T, and then S goes with S. So there we are.